For thousands of years, humans have longed to fly, to soar into space. In order to explore the sky, they even resorted to firing cannons into the air, just to see what impact a few kilograms of lead bullets would have on the sky. This aspiration gradually became a reality with the development of modern science and technology. After the invention of hot air balloons, humans were finally able to fly into the sky and return safely. However, people were disappointed to find that ordinary human bodies could not withstand the harsh conditions of high altitude. The cold and thin air claimed the lives of many scientists. After World War I, aircraft flew higher and higher. This more maneuverable aircraft provided a new platform for human development in the sky. In order to adapt to higher altitudes, early simple pressure suits were introduced. In 1938, Italian aviator Mario Pezzi flew to an altitude of 17,080 meters, wearing an early prototype pressure suit, setting a record for piston engine flight. Although these aviation pressure suits did not reach the level of spacesuits, they laid the technological foundation for the latter after decades of development. Compared to the pressure suits used by pilots, the spacesuits used by astronauts are more complex and larger in overall structure, especially considering tasks such as spacewalks or moonwalks. Spacesuits require a fully equipped life support system, which is generally located in the backpack behind the spacesuit. The life support system is a complex set of mechanical devices that need to consider the astronaut's ability to operate independently for a certain period of time after wearing it, including continuous oxygen supply, heat dissipation, and water replenishment. To accommodate so many devices in such a small backpack, this backpack is undoubtedly high-tech. Currently, only a few major spacefaring nations in the world have independently developed spacesuits, indicating that this set of equipment is not simple. Take the Russian Orlan Spacesuit as an example. It is a one-piece hard helmet spacesuit that has been used on the Mir 7 space station and the Mir space station. It is a highly mature piece of equipment. So, what does the backpack of the Orlan Spacesuit contain? Let's briefly understand through a set of illustrations. The Orlan Spacesuit allows astronauts to enter from the back by opening the backpack. Its integrated design eliminates the need for external hoses, and astronauts can make adjustments through the control panel on the chest. From the opened backpack in the illustration, we can roughly see its internal structure. 1. Monitoring unit. Equipment used to promptly monitor the operation of various systems. 2. Primary and backup fans. Fan devices. Wearing such a tightly sealed suit, astronauts quickly generate heat and sweat. The fan devices help circulate the air and increase comfort. 3. CO2 removal cartridge. Equipment for removing carbon dioxide. Astronauts need to breathe, and the required oxygen is supplied through tanks. However, as astronauts breathe, the spacesuit accumulates exhaled carbon dioxide. This device removes carbon dioxide to maintain the oxygen level. 4. Feed water tank, water supply tank. Spacesuits require a certain amount of independent operational capability, such as the Orlan Spacesuit, which can support 3 hours of independent operation. Astronauts easily become dehydrated in the stuffy spacesuit, so necessary water replenishment is crucial. The weightless environment of space also presents different requirements for water supply, posing a small challenge in maintaining suitable water pressure and flow rate for astronauts. 5. Heat exchanger. Device for heat exchange. Astronauts generate heat inside the spacesuit, and relying solely on air circulation within the suit is not effective for cooling. The spacesuit is equipped with many small-diameter tubes, which use internal circulation to remove heat from various parts of the suit through the heat exchanger. 6. Moisture separator. Device for separating moisture. Its function is similar to a dryer, ensuring dry air inside the spacesuit. 7. Telemetry unit. Unit for telemetry. 8. Primary oxygen bottle. Oxygen supply bottle. It provides pure oxygen for astronauts to breathe, rather than the mixture of oxygen and nitrogen found on the ground. 9. Battery. power supply for various electrical systems in the spacesuit. 10. Radio station, important equipment for communication between astronauts and the outside world. 11. Boot, spacesuit boots. 12. Lower soft torso, soft lower bodysuit made of various fabrics. 13. Pump. 14. Underwear, inner lining that astronauts wear before putting on the spacesuit. 15. Water cooling garment, water-cooled suit. It removes heat from inside the spacesuit in conjunction with the heat exchange device. 16. Hard upper torso, hard shell structure of the spacesuit. 17. Pressure regulators, pressure control devices. 18. Backup oxygen bottle, backup oxygen supply. Although the spacesuit has such a large backpack, there is not a bit of extra space inside. It is packed with various systems. Even so, this spacesuit can only sustain normal operation for 3 hours. Currently, when developing the next generation spacesuits, researchers tend to eliminate this large backpack to increase flexibility. As for what future spacesuits will look like, we can only wait and see decades from now. However, if humans want to walk in space or on the surface of the moon, a life support system is essential. It's just that, with the advancement of technology, the size may become smaller and more portable.